Hello everyone, I am Dr. Abha Kumari. Today we will discuss some more problem from integral calculus, and the chapter we have taken is area of planes. In this chapter, the question we are going to solve is find the area of the curve x square plus y square equal to a square. So to solve this question, we have to first find the tracing of the curve. So let us first trace the curve. The first point is the curve does not passes through the origin. So why this so? Because while putting the value x equals to 0 and y equals to 0, our left hand side becomes 0, but right hand side is not equals to 0. Okay, and since 0 not equals to a square, that's why we write that the curve does not passes through the origin. Now the second point, the curve is symmetrical about both the axes. While putting x equals to minus x and y equals to minus y, we see that there is no change in the given equation of the circle. That's why we say that the curve is symmetrical about both the axes. Okay, the curve is symmetrical about both the axes. Now third one, put x equals to 0. This implies y square equal to a square, and this implies y equal to plus minus a. And again, by putting y equals to 0, we get x equals to a square, and this implies x equals to plus minus a. Fine. That is a0 minus a0, 0a, 0 minus a are the points where the curve cut the x-axis and y-axis respectively. Okay, so let us draw the figure by taking all these 3 points. So here we have O as origin, x dash, x, y, and again here we have y dash. Since we have a point here is a0 minus a0, okay, minus a0, here is 0a, and again we have 0 minus a. So we will join these points and we get a circle. Okay, like this. Let this point be this one and this be this one. So let this point be A, this point be C, B, and then we have D. So this is a equation, a figure of a circle of radius A. So here A, B, C, D, A, C, B, D, A be a circle of radius small a. Okay. Therefore, the required area is equals to 4 times the area of the portion OAC, like this. Why? Because the curve, this circle is symmetrical about both x and y axis. So, or CACB is equals to BDA, and if we put only this section, then what we see here is 0AC is equals to CBO, and OBD is equals to DAO. That's why we have written here 4 times the area of the portion OAC, and this is equals to the area between the curve CA, okay, the x-axis and the y-axis, or the ordinates x equals to 0 and x equals to a. Okay, this one, an ordinate x equals to 0 and x equals to a, this one. So this points becomes our limit points. Therefore, now this thing is equals to 4 times integration over 0 to a y dx. Okay, so 4 times 0 to a. So we have to find the value of y, since it is portion on the right hand side. That's why we are taking here a y, and the value of the y here is y equals to root over a square minus x square. Fine. So let us put this value here. So 4 times root over a square minus x square into dx. To solve this integration, let us put the value x equals to a sine theta. So here we are putting the value x equals to a sine theta. So put x equals to a sine theta. So this implies dx equals to a cos theta d theta. Now when x is 0, r theta is 0, this implies when x is a, this implies theta is pi by 2. Why? Because here is a, so this is equal to a sine theta, and this implies sine theta equals to 1, and this will give the value of theta as sine inverse 1, and this is pi by 2. Fine. Therefore, integration 0 to a root over a square minus x square dx will become 0 to pi by 2 root over a square minus a square sine square theta into a cos theta d theta. Now this thing is equals to 0 to pi by 2. Now a is common, so, and again ab, so here we are getting a square. Now root over 1 minus sine square theta is cos square theta, and cos square theta we are getting only cos theta. So a cos theta, and again we have cos theta, so cos square theta d theta. So now a square is taken outside, so we are leaving with 0 to pi by 2 cos square theta and then d theta. Now earlier we have seen the reduction formula chapter. In this chapter we have learned, while we have an even number of the power, then we will write it as a square into 2, 1 and then pi by 2. So this is what a square. Okay, and earlier we have what? We have the 4 times of the required area. So this is what? A square pi by 4. Therefore, the required area equal to 4 times 0 to a y dx, and this is what? 4 times 0 to a root over a square minus x square dx, and this value is 4 times a square pi by 4. 4 and 4 getting cancelled, so we have the value as a square pi. Therefore, this is the answer. Thank you.